how many people do we have on your side?
We have 6 here. 6, not including myself.
Okay.
I think
people that want to learn about enterprise application integration. I see. Okay. So guys, if you want to ask any question, just do so. You should be able to basically interrupt whenever, wherever you need to ask something or to do something. On this side, basically the students have to press a button to speak, and when that happens, the camera will be on them, but it should return to me. I'm actually not able to see what image you are receiving, so I don't know if you are seeing me okay or not. So if you need to readjust the camera, please do so, and it's not a problem. Okay?
Sounds good.
Hi guys.
Those guys have. Not everybody in the class has, but there's 60 people in the class.
Are you the only two who are taking this class, or?
6
Okay.
Everybody's kind of lost.
Yeah.
3 more people.
Yeah, I think everyone is kind of lost with this room because this is really in the dungeons of the civil engineering department. It doesn't look like a dungeon, but it's kind of a dungeon. Hurry up.
Everyone's online?
Press the button, and the students press the button, the camera goes right to them. Makes it nice for, we don't have such a system here. Makes it nice for the distance ed.
Okay, I think that probably we can get started. There will be some more people coming because actually there are 90 people enrolled in the course, so it's a lot of people, and it's actually just me teaching it, so I expect a lot more people to actually come in and find the room. Welcome, my name is Paulo Marques. I'm an assistant professor at the University of Coimbra, and I'm an associate teaching professor by Carnegie Mellon. And this is going to be an interesting experiment because it's actually the first time that we are going to be teaching a synchronous class from Portugal to CMU also. So there's actually some nice students and some nice people on the CMU side who will be participating. And basically this course is about enterprise systems and actually about how to integrate large-scale systems and large-scale enterprise systems. And just a quick note, my office is D25. Probably most of you already know me and know where I live most of the time. There's another professor, another instructor that is going to be teaching the course also, whose math boss is in the center of the image. Say hi, Math.
Hi there.
So he'll be monitoring the course and helping the students on the CMU side, and it's going to be a funny experiment. So what's this all about? What are we going to talk about? In many courses, and probably in the distributed systems course, you actually heard about this thing called tiered systems and two-tier systems and three-tier systems. And a very common architecture nowadays in terms of information systems is to have a three-tier system with a presentation layer, a business logic layer, and also a database layer. So this course is actually not about that. My assumption is that in general, at least at the level of concepts, you have an idea of what a three-tier system is and how it's developed. Although there will be a project where you will develop such a system, a small one but a representative one. But the assumption is that you already know or have the concept of a three-tier system. In reality, what we are going to talk about is how to integrate these kind of systems with another system similar to them, and how to do this in a large-scale environment. So let me give you an idea of the kind of things I'm talking about. And again, if you want to interrupt me, just press the button and speak. And if you guys want to interrupt me, please do so. So imagine that you are at your computer and basically you are doing a purchase at Amazon on their website. What happens when you do this is that in reality you are kind of contacting with the server, right? Which in general it's a three-tier system and has some kind of mechanisms for it to be scalable. So in general there's something like a load balancer in front of the system and several application servers and so on. But if you abstract it, basically it's a box. So imagine that you are actually trying to buy 2 books and doing an order for 2 books. Well, somehow this system has to be able to contact a different system. Possibly it has to be able to contact the warehouse of Amazon, right? Actually, Amazon has several warehouses, but what you see is that you have a large system which takes care of orders, and in general you may have one or more large systems which actually take care of all the management inside the warehouse, right? And let's suppose that actually the books are not available. If the books are not available, what has to happen is that somehow Amazon.com must have a way to put an order to Prentice Hall, which is a completely different entity, it's a completely different company, and somehow they have to have an agreement on how to communicate, right? But if you are buying 2 books, somehow Amazon also has to have an idea on how to talk with, let's say, O'Reilly, and actually O'Reilly has to have a way of sending the books to Amazon and sending the invoices and so on and so forth, right? So let's imagine that Amazon is actually buying the books from these 2 bookstores, these 2 different companies, and the books actually get back or are delivered to the warehouse. So what happens at that time is that somehow the warehouse, this system which is autonomous, it's not depending on the main billing system, has to have a way to contact the main billing system and say, listen, the books are now available. You can actually make the client pay, or you can actually dispatch the books to the client, right? Again, 2 different systems talking among themselves. Well, but in reality it doesn't stop here. What does Amazon have to do besides this? Sending the books and so on. Okay, Amazon has to ship the books, that's correct. But there's a very important thing that Amazon has to do also. Billing. The reason Amazon exists is that they want to make money, right? So somehow Amazon has to have a way to talk with Visa International or MasterCard or American Express, right? But actually, MasterCard or Visa, they don't know how to get your money. So somehow Visa has to have a way to talk with your bank, right? And bill your bank. And in this case, the bank is a Portuguese bank, CGD, right? So you see that in reality, many times in many courses you have a very, let's say, narrow view about what an information system is, and you see just an application silo which is very vertical with the database layer, the business logic layer, and the presentation layer. But in reality, companies are doing business between themselves, and somehow they have to come up with an agreement regarding interfaces, exchange of information, transactions. Imagine, you cannot have the money being lost between two banks. You cannot lose purchase orders and so on, right? There must be ways of actually developing this kind of systems. And this is exactly the things we are going to talk about in this course. So, we are going to be discussing technologies and ways to actually integrate large-scale systems in a robust way. In many cases, these systems are administered by different entities, different companies. Okay? That's the main objective of this course. Questions so far? Nothing? Okay. So, the main objective, let me give you a little bit of history. In general, what happened over the years was that companies would develop these systems, these applications, which solved a particular problem, but with the internet and networks and companies wanting to do business electronically, what happened was that they started to have to need to talk with different systems. And what happened? Well, basically the developers and the guys managing the projects went to the code. Okay, I need to talk with that system. That's easy. Let me open a socket to that system. I'll send it the information and that's it. But then that system basically opened a socket to a different system. And over the years, what started to happen was that people were doing what's called point-to-point integration. Point-to-point integration is when this specific system is talking with that specific system, and that specific system is talking with another specific system. And after a while, no system knows, or no one knows, what systems are talking with what systems. And I don't know if you've heard about Leslie Lamport. Do you know this name? So Lamport is one of the fathers of distributed systems, and he has a very funny definition of what a distributed system is. What he says is that a distributed system is when a computer that you didn't even know that exists makes your system crash, right? Because, well, it's somewhere, it crashed, and somehow it cascades back to you. And that's exactly the kind of things that we want to try to evitate. So, let me give you a little bit of context. In general, when you build systems and applications, basically you are concerned with databases, networks, things like software engineering, programming languages, and you get these nice boxes with very vertical systems. The thing we are going to talk about is how to actually connect these boxes. We are going to talk about things like service-oriented architecture. We are going to be talking about things like enterprise service bus. We are going to be talking about things like long-running transactions, which involve several entities. We are going to talk about things like standards for integrating applications across many organizations. Yeah. So, and the reason this is so critical nowadays is that if you actually look at the statistics, I didn't put the reference where this came from, but I can give it to you. In general, studies say that between 70 and 90% of software costs are maintenance, which means that after the system is built, actually the companies who build the systems are making the money from the maintenance and not the selling of the system itself. So there is a large pressure to actually lower maintenance costs. Again, if you do point-to-point integration, that's not going to work. It's always going to be a mess. Nowadays, in many systems, again, mostly in information systems, a large percentage of code is actually living in the database, which, in my opinion, is really awful. But if you go to real systems, you see a lot of code written in PL/SQL and things like that actually inside the database. If you look at Oracle, for instance, they actually have a virtual machine inside of the database because, well, they want to run Java code inside the database and highly coupled to the database, which, again, it's not really a good solution. So, in general, doing enterprise application integration in a sort of ad hoc way is really a problem. What we want to learn and what you want to do is, how do I design a system which easily integrates with another system? How do I create an architecture or a software that is reusable across the organization? Not at the class level, but at the system level. And this is really important because if you look at it, nowadays, every single system that you have is interconnected. If you are convinced that you are going to develop a system, an application, which is not going to talk with nobody else, you are completely wrong. Sooner or later, it may seem that way in the beginning, but sooner or later, someone will want the data that you have in your system. And basically, you will want to connect to a different system. If you haven't thought about that in the beginning, it's really going to be crazy in the end to do it. And as I told you, software is constantly evolving. What this means is that basically you don't create a single project or a piece of software and that's it. Basically, when you create a piece of software, the software is going to be long-lived in general. So the software must be prepared for that kind of evolutions. Okay? Again, if you want to ask questions, please interrupt me. You are a little bit quiet, but it's after lunch. So what's the objectives? We are going to talk about enterprise application integration and business-to-business systems. There's going to be a particular focus on service-oriented architecture and enterprise service bus, but we are going to talk about much more than just SOA and ESP. We are going to talk about standards, we are going to talk about technology, we are going to talk about security, we are going to talk about deployment. How do I put these in terms of machines in the field? Do I have to have things like load balancers? Do I have to have replication? What's a failure model for a system and so on? And one important thing is that this is a very technology-oriented course. What this means is that my belief is that you can only understand the problems involved in doing application integration if you actually code a system or several systems which are at least of a certain size. And because if it's too small, then you are just developing normal applications. So this course will involve some coding and some, well, 4 projects of medium size, and it's very hands-on. What are the assumptions? I assume that you know a little bit about distributed systems and network programming. Not a lot. Basically, I assume that you know what a remote procedure call is, or you know what opening a socket to a different system is. And I assume that you know a little bit about database systems. So you know what a database is and what a table is and what a select is. Okay? So not a lot, but something that you do need to know about. I already covered this in my talk. Basically, we are going to start by talking about XML technologies, and actually the first assignment is going to be about XML. We are going to talk about web services and second generation web services, which is an evolution over normal web services. We are going to talk about architectural patterns, things like service-oriented architecture and enterprise service bus. We are going to talk about the supporting technology, which is normally called middleware, things like transaction monitors, things like distributed transactions, long-running transactions, message-oriented middleware, business activities. We are going to talk about integration with legacy systems. So I have a box that has been running for 10 years. What's the correct approach to putting that system into a service-oriented architecture, for instance? Talk about standards for having two different organizations talking with themselves. We are going to talk about security, of course, because if it's large, it's going to be attacked, and we need to know some things about security to design it properly. And to conclude, we are going to talk about reliability, fault tolerance in enterprise systems, not from a, let's say, theoretical point of view, but from a practical point of view. What do I normally do in this kind of systems? Okay. Two main books, although I don't recommend that you buy them. Well, the first one you can buy it, it's really good. But the reason I'm saying I don't recommend that you buy them is that, at least as far as I know, there isn't any course available nowhere that covers so many different materials in terms of enterprise application integration as this course. And what this means is that no book, at least the ones I know, actually cover all the things that I've put in the syllabus and that we are going to talk about. So, for instance, enterprise integration patterns is really good for giving you a language about enterprise systems, and it's really good about messaging systems, but it doesn't cover things like deployment of systems or security or business partners or long-running transactions. For instance, the second one it's a quite okay book about service-oriented architecture, but again, it's mostly about web services, implementing it using web services. And you can do a service-oriented architecture without using web services. So all the books that we are going to be using are available in the library, but in general, if you read the things that we will be providing you and the papers and if you do the assignments, that should be enough, okay? And you can always read the corresponding sections, and you should, of course. Okay, how are we going to organize ourselves? There's going to be theoretical classes like this one. I hope it's not so theoretical that you cannot relate to reality. In general, I'm a very practical and pragmatic guy, so the things that I normally talk about are things that you can actually implement in the field, in the real world. We are going to, in these classes, have, let's say, a bird's eye view about the important things and how you should design the systems at a higher level. We are also going to have an open lab and projects. What this means is that basically you are going to have 4 projects to do. The projects are to be done in groups of 3 students, and it's about designing a certain number of applications or designing a certain system, okay? When I say it's an open lab model, what this means is that, as you know, at Friday there are 6 hours of, let's say, open lab or TP classes, how they are called here, for enterprise application integration. What this means is that you don't have to come to a particular class. I'll be there all day. If you want to come in and sit for 2 hours and implement part of the system, it's fine. If you just want to come in and ask some questions or have some doubts answered, that's also fine. If you want to spend the whole afternoon in the lab, it's also fine. So different students find different ways of using that time, and my advice is make use of that time as you need. One thing that I ask you is to actually try to show progress weekly. if you try to leave the projects and the assignments to the last day or to the last week, it's going to be impossible to implement it because the systems are basically too large for you to be able to do it, let's say, in a week. So don't postpone to the last day. Start immediately on the first day, okay? By the way, the first project is already available online, but we'll talk about that in a moment.
But we have to show you our progress. We have to show you what we've done so far.
I would like to see it. You don't have to do it, but I encourage you to do it. The reason I'm not forcing you to do it, it's very simple. Although there's not 90 people here, actually there's 90 people enrolled in the course. And I cannot see progress on, let's say, 30 projects in the time available for the labs. But again, if you have questions or if you want to have something answered or if you want to show me something, please come in and show it. By the way, when you need to ask a question, please press the button and speak to the mic because the guys on the other side will not be able to hear you, okay? So, another thing is that because this is a synchronous course and the classes and the schedule is not exactly the same on both sides of the ocean, classes are going to end in different dates at CMU and for MSc students and for normal MSc students here in Coimbra. So, as you know, the people who are doing the Informatics Engineering Masters classes end on the 18th of December. People doing having classes at CMU and doing the MSc, the classes end on the 4th of December. So the model has to be a little bit adapted for these two audiences. So in terms of projects, it's okay? Okay. So in terms of projects, the projects should be done in groups of 3 students. Please don't start asking me to do the project by yourself or to do the project in groups of 2 because in the end I've been down that road and what happens is that at the end I'm seeing 90 times 4 projects, which is 360 projects, and the projects take a long time to see, so please don't do that. Try to keep it to 3 students, so find a group and define a group right away. We are going to use something called late days, because at least the students doing the informatics engineering degree in general have crazy deadlines and deadlines on top of deadlines. So the late days, what it means is that if the deadline for a project is at a certain date, you don't have to necessarily deliver the project on that date. What happens is that if you deliver it 2 days later, you've burned 2 late days, okay? What happens is that in the 4 projects, you can burn up to 8 days. So imagine that in the first project, you deliver 1 week later, right? The following projects, basically you have to deliver them on time. Imagine that you burn 2 days on the first project because you have a deadline with another thing. Basically you have 6 late days left for the rest of the projects, okay? For the local students, the defenses, you know that you have to defend the projects. The 4 projects is going to take place in January, as usual. The defense takes about 1 hour, and it's about 15 minutes per project, okay? Students at CNU and MSc students, because you end earlier, basically it's a little bit difficult to do the final project. So the idea is that you do 3 projects instead of 4. Because you don't have to do so many projects, basically you don't have 8 late days, you have 6 late days. And the defenses will take place in December because the semester actually ends in December. If you want, you can do the fourth project. It will be available before time. I strongly recommend that you do it because it's really a cool project and it's about message-oriented systems and distributed transactions, so it's really a cool project. If you do it, basically you can get extra credit for the project, which means that if you do well, the grade is probably going to be, well, it's going to be a little bit increased. Questions about the projects?
So just a quick comment for the people on this side. Here we're not typically so used to this notion of an oral defense. So this is just an oral final, where you guys are asked a series of questions about the projects that you've done, and you have to defend the decisions made and so forth.
Exactly. So the idea is that when you do the project, you also deliver a small report. And basically, during the defense, the instructor will ask you, why did you model this piece of information this way? How do you address the case when there is, let's say, a new value in this case? In what situations will your design crash, for instance? Okay, so basically the instructor will try to assess how robust or why you took some design decisions while implementing the project, okay?
So no coding in the defense.
No coding during the defense, okay? So it's a normal project defense as you normally do here. Please press the button.
Sure. Just asking if we can get any extra credit also.
Well, you have to do the project, so no extra credit.
Okay.
Okay? Okay, more questions? Any questions? The students at your side are really quiet. By the way, guys, can you introduce yourselves? I'm not going to ask all the people in the room to introduce themselves, but...
About the open lab. Is that
So we had a question here first, Paul, if that's okay.
Okay.
So I'm not familiar with this open lab policy. I guess how is that going to translate over for us? Do we just work with Matt?
Exactly.
Yeah.
So in the case of math, you have a recitation. I think it's on Wednesdays.
Right.
And sorry, math.
Yeah. So on Wednesday we're gonna have a recitation, and you guys so basically a period of time when you can come with questions. So it's not going to be an open lab where you kind of come and sort of work in my office, but we have a recitation here, and you hopefully will have questions prepared.
Exactly.
So if we can just go around the room, start. Adeline, you want to introduce yourselves?
Well, exactly. My name is Adam. I'm an MSc student, fourth semester. I'm from Kazakhstan. I have a 2 years experience in industry, almost 2 years experience in web development. I'm taking this class because I'm interested in knowing more about the service-oriented architectures. I think as everyone here, that's basically it.
Okay, good. Yeah, we could just quickly introduce yourself. And
My name is Michael Keeling, fourth semester MSc student.
Okay, that was great.
I am Aparna. I am also fourth semester MSIT student.
Okay, excellent.
Hi, I'm Vignesh. I'm also first student MSIT student.
Okay.
Hi, I'm Sai Sharan, fourth semester MSIT student.
Okay.
Hi, Suprema, final semester MSIT student.
Hi, I'm Reno. I'm first semester MSIT student.
Okay, cool, excellent. I'm not going to introduce everyone in the room. Okay, so grading. Again, it's going to be a little bit different for the two different audiences in the course. Local students, you have a final exam that's half of the grade, and you have 4 projects to do, which is half of the grade. you have to have at least 35% in each one of the projects, which is the minimum grade in the projects. If there are working students taking the course, basically because the deadlines are so sparse, you have to submit the assignments on the same deadlines, okay? Again, this relates to the way it works locally, so it doesn't translate to your side, but if you want to be admitted to exam, that means that you actually have to have the minimums in the projects, okay?
25%?
Yeah, in each project, okay? So you do need to complete the projects. You cannot just come to the exam and do the first project and expect to pass the course, okay? CMU students and MSc students, there's a final that's off of the grade also, and you have 3 projects for 50%. If you do the 4th project, you can get your grade increased, let's say. The exam is closed book, except that you can bring some notes. Basically, you can bring 2 sheets of paper, which means 4 pages of notes. The exam is not about the tiny little greeny details about the things. It's about concepts and things that you should know even without having any kind of notes. So it thinks how would you design this, or what's the problem with this approach, or what does this concept means, okay? I will provide you some sample exams from last year and the year before at the correct time, okay?
Do you have a date for the exam?
No, it's going to be settled. Well, in your case, as you are MSc, it's going to be somewhere in December after the classes end. Okay, so it's in the exam week, basically.
We have a date.
Just press the button.
Okay, just one question. For working students, you think it's possible to increase the buffer size just in case we have concurrent deadlines in work and in the project?
That's why you have the late days. So you have to manage the deadlines with 8 late days. And 8 late days is actually, I've been using this for 2 years now, and it's more than enough. Since I introduced them, it wasn't a problem anymore.
Can you press the button again? We're still looking at the back of the class.
Okay.
Thanks.
So the learning management system that we are going to be using, it's Moodle. So it's on the University of Coimbra. This applies both to students in Coimbra and students at CMU. So please go to that address. You have to create an account, and then you should enroll in the Enterprise Application Integration course. You have an enrollment key. The enrollment key is EIA 2009. Okay? When you do that, you become a student of the course. Okay? All the materials, all the lecture notes, all the projects will be there. The Dropbox to actually submit the assignments is also in this system. And I can even show you if I have, I do have network.
How can a warning apply to our...
I think they're recording it. I think it's the recordings. I hope.
We'll just shut off.
We were having a little trouble.
So I don't think I'm in the correct course because this is boot camp, and you are not taking boot camp. But so if you go to Enterprise Application Integration, this is
good version.
Yeah.
Well, I guess
I'm going to show it as if I was a student. So there's a couple of important things that you can see. On the top, you can see that you have the syllabus for the course. The syllabus has a very detailed plan about the course, including the dates where there will be no class, and some dates there's going to be 2 days where we will not have classes. So you have the week with the date, the topic we are going to talk about, what's involved in terms of reading, and so on. Okay, for instance, on the 16th of October, there will be no class, and you should put this on your schedule. On the 23rd of October, in the afternoon, there will be a makeup class, which means that there's going to be an extra class. If you cannot attend, all these sessions are being taped, actually, so you are on camera now. I hope it's not a problem for anyone, and they will be made available offline if there is a problem and you can't come. Okay, the 2 other important things is that, so you have the syllabus, there's a QA forum, which means that if you have a question, either for me or the other students, or if you have an announcement or something like that, basically you should post it here and everyone will receive a message, okay? And what I expect is that most of the communication about the course should go through the board, because if I have to answer the same question 90 times, it's really complicated, and sometimes actually some of you will be able to answer the question. And when that happens, especially in terms of projects, I do appreciate that basically you answer questions that other people know how to need answers. Let me give you an example. In the second assignment, you are going to design a system which uses JBoss, which is an application server, and you have to configure part of the application server. And sometimes there are some problems with where to put the jar files and so on. So basically, if someone asks a question and I don't know the answer, or Matt doesn't know the answer and you know the answer, you should provide the answer, okay? It's perfectly fine. The things for which you should not provide the answer is actually how you are designing your system, right? So if you are modeling information in a certain way, that's not the kind of thing that you should share with other people, okay? But things like infrastructure or general questions, you should try to make use of this. It's really useful. As you can see, the first project is already posted. You have we don't have a lot of network in this room. Okay, anyway, inside this folder you have the description of the assignment, and you also have some support material. The support material is basically some examples in terms of code that you can actually use to start up with your project. For each project there is going to be a discussion forum, which means that if you have a question or an observation about
Oh, the audio went out on our side for some reason.
The 5-minute deadline?
Yeah, the mic just died. Just give me a second.
Okay.
The battery.
Oh. Spare batteries.
Matt, can you hear me?
Yep. Great.
Okay. So
Thanks.
I had a little bit of risk mitigation because this has happened in the past, and I can use batteries.
We're all impressed.
So again, if you have a particular question about a particular project, you should use the forum for that project. Finally, you have a Dropbox for submitting this project. There will be a Dropbox for each project, but after you complete the project, basically you submit it here, okay? A zip file, etc., etc. The description of what to submit is in the assignment. Okay. Press the button.
When are the delivery dates?
Okay. So I can show you that. So again, to know that kind of thing, if you go to, that's described in the assignment, and if you need to know that, you should go to the syllabus. So you see that the first assignment was published today, and the due date is going to be when the second assignment is published. So the due date is the 2nd of October, okay? Oh, okay. I will correct that. Do you still have your button pressed? Okay, cool. Do you guys have any question on your side? On the CME side?
Any questions over here? I think we're good.
Okay. Okay. So again, the syllabus is where all the information about the course is available.
The recorded class will be on Moodle too, or not?
We'll only make it available if they are actually necessary, because what's going to happen is that if we make it available immediately, you are not going to be showing up to class. So we'll make it available on a cases by cases need, but when the semester ends, it's very likely that we'll make everything available so that you can review the lectures. But not at this time. We are not going to publish all the videos because I know how it goes.
From our experience in the United States, in analysis, the videos are very helpful for the exam, for preparation.
And we will make it available before the end of the semester, but we'll not make it available immediately like today. We'll have it, but we'll put a delay of 2-3 weeks before we make it available, because I know what happens when people have the videos. They basically don't show up, okay? Again, if you have a problem and by exception you couldn't attend the class, you can send me an email and we can figure it out, okay? Okay, why should I care? That's an important question. I've been running this course for 3 or 4 years now, and what I can tell you is that it's one of the most, let's say, successful courses at our department. What I can tell you is that there are several students which actually were hired because they did this course and they had a lot of knowledge about enterprise application systems. I was contacted by companies that were trying to recruit people doing the course. I had people that basically were saying that this is exactly what they need, and this is something that industry right now actually quite values. I know this is in Portuguese, but this is a student saying that basically he was hired because he did the course. This is a company saying, this is exactly what we need. We found your course on the web. Can you give me contacts of students and people taking the course because we want to hire them? Again, a lot of companies, when they see that people have the sort of knowledge that they get in this course, they are really let's say, ready to hire people. So this is the kind of things that it's quite interesting and quite rewarding about this course. So the main idea is that let's have fun with it. It's really a cool course, and I think you will learn a lot. Questions about the course in general before we move into other things. Is everything clear? Okay, excellent. Okay, so let me close all this. Okay. Okay, so the first topic we are going to talk about is about XML. I'm pretty sure that all of you have used XML. It's almost impossible to be a CS major nowadays without doing things using XML, but we are going to take a little bit of a detailed look into XML and why it's used and what's the relevance. Also, your first assignment is going to be about XML processing. Because let me tell you two things. The first one is that there are certain topics which I'm not going to cover in detail, like XML, because they are so ubiquitous and most of people already have at least an idea of what's involved. But the slide deck, which are actually lecture notes, are very complete and you can use them as reference. This means that I'm going to skip some of the slides and basically I'm just going to talk about the important things. This is especially true in the first chapter, which is about XML, because I just want to give you an overview, and for the details you can actually look into the project and the biography present in the project. So I'm going to go very, very quickly about the reasons for XML, and I'm going to give you a small overview about the project that you should start working right away. Okay, so why are we talking about XML and what's the relevance and how did it came to be? And the problem is an old problem, and if you had distributed systems, you know all about this. What happens is that you have a lot of different systems that have different architectures. For instance, you know that, well, nowadays it's different, but the Motorola processors that were in the Macintosh family of computers would represent, for instance, integers in a different way that PCs would represent them. So even if you were sending low-level detail like an integer or a float between computers with different architectures, there were problems in that. But even when you raised the abstraction level, and if you looked at applications and things like that, basically you had problems with the schemas and the data model. So you know that both Word documents and PDF documents represent, well, documents, but basically they are not interchangeable, right? So if you send a document to a different system that doesn't know how to handle it, it's a problem. And in general, what happens is that you have to have some way of transcribing the information from a certain schema, from a certain type of data to a different type of data. Okay, so this was the main problem that people were trying to address, and people tried to address this over years and years and years with problems. Some people say, oh, but if I do everything in Java, it's great, because Java is ubiquitous and so on. Well, not so. Java, for instance, is just a tool. And many systems are not Java-based. And actually, if you look, imagine that you are sending data between two computers using the Java serialization format. Well, that's just a format for transmitting information, right? Even so, when you have the information, probably it would be not a so good idea to start the information using some kind of standard that was developed just for transmission. And some people try to do that, but that doesn't really fly. So there were a lot of formats for doing this. For instance, Sun had a format called XDR, which was very used. Corbat had a format for doing this, but, well, it really didn't work. And in general, when you are talking about enterprise systems, one of the things that you will see is that you are really late, guys. Come on, hurry up. One of the things that you will see is that in general, enterprise systems are not about remote method invocation. Many times, enterprise systems are about sending documents, structured information between places. For instance, imagine an invoice. When you buy something, someone sends you an invoice, right? An invoice is a document. It's a legal binding thing. So if you just try to define a format using Java or something like that, that is very low level or just oriented to the remote method invocation, that doesn't really work. So, someone is beeping. Okay. Okay. So in general, there is when you design a system, there are two different things in terms of data that you have to consider. One thing is formats for storing data and storing information. Another thing is formats to actually transmit information. And some of you may object and say, well, but I put everything into a database. Well, it's also a problem because in general the formats of databases are also proprietary, which again create a lot of problems. So going back to business, well, what happened is that when you have a business, in general, you need something that is readable both by people and machines, and somehow is able to be automatically processed. And you say, okay, I'll use HTML. That can be read by people and processed by machines. But this is stupid, right? Because, well, HTML is basically to show information. You have tags like bold, italic, and so on. But again, that's just about the presentation. It's not about the content. It doesn't work that way. Okay? So some years ago, some guys, with the help of a company called Procter & Gamble, but not just them, they defined a standard called EDI, Electronic Data Interchange, which was later standardized as ANSI X12. And this was a standard that many companies were using to actually send information among themselves. So imagine that you are making a purchase order to Continent or to something like Walmart in the United States. Well, if you need to purchase something in bulk, probably you'd send an EDI document to them, and they would respond with an EDI document. Okay? Well, the problem about this is that this is what an EDI document looks like, which it's not that user-friendly, right? And this is the kind of things that you actually see, okay? The kind of forms that you define ending up being things like this, which did the job, but were really not so easy to process or for people to understand. Looking at it, I'm really not able to see it's an invoice, although if you look careful, you will see that there is a company which is Wiseco of America and a certain address and so on. So the information is there, but it's not really readable. And things evolved, and nowadays mostly people use XML to do this. And XML is basically a subset of a general language called Standard Generalized Markup Language. As you know, it's tag-based, so I mark everything with tags, and the documents are actually seen as a tree, okay? It's extendable. What this means is that I can define a schema for information. I can say that an invoice is something that has the person who is making the purchase, it has the person who is actually delivering the good, it has the price, and so on. So I can define tags, and I can define schemas for different businesses. XML is text-based. It's independent of storage and actually independent of transmission mechanisms, okay? I can send XML over the wire in a socket or by email, or someone is again beeping.
There's a machine.
Yeah, there's a computer. Just turn it off. Okay. So, as you know, XML basically looks a little bit like this. You have a prologue that says, okay, this is XML of a certain version. You have tags. The tags are actually formally called elements, and there's always a root element from where everything starts. You have something called attributes. Attributes are pieces of information that classify a certain tag, and basically you have the information, the data between tags, okay? So in this case you can see that the CD, which ID is number 2, has the title Who, Her, and was recorded by an artist called PGRV in 2004, okay? So in terms of businesses, and we will see that later on with the standards for integration, what people are doing is defining schemas for being able to conduct business across a certain domain. So for instance, if I want to buy things from Walmart or Continent, there's a schema that specifies the kind of information that they need, and so on and so forth. Okay, I'm not... Yeah, press the button.
Just a small question. Isn't JSON already replacing XML as a more human-readable format?
Mm-hmm. Okay, so JSON is a JavaScript object notation, which is it's also a standard, and it's a standard for basically defining data structures, which is based on JavaScript. JSON is being very, very used to actually replace XML and web services when calling between different machines. And the reason for that is that basically you know that web services, or you may not know, but you will know after this course, web services are really expensive and very, very slow. And one of the reasons is that they use XML for everything, okay? So many people are actually replacing the XML when they are doing remote invocations by something called JSON. That's true for remote invocations, but for storing data, like storing an invoice, what I want to do is not just to store the data structure. I want to really store a document that is structured and that later on I can basically process in an efficient way. And for that kind of purposes, JSON is not great, because again, JSON is very oriented for transmission, okay, for the invocations, but not really for storage and being able to query those structures.
I think there's a difference. I don't know if it's really true, but I guess in XML you have like the encoding on the XML, while in the JSON you have the encoding supplied by the web browser. The web server. Encoding, for instance, is delivered by the headers, not in the data. And you don't have schemas.
Again, press the button. Again, it goes back to the question I was mentioning, and that's true. JSON is really oriented for the connections and remote invocations, and it's really good when you have HTTP or something like that has the wired protocol. If you really want to storage thing, or imagine that you receive an invoice from a company. Basically, you have to check that invoice against a schema to see if the invoice is properly formatted. That's the kind of things that JSON doesn't address, because JSON is mostly a wired format. It's not really something to represent data in the long term. Okay. Okay. Again, I'm not going to look into XML in very detail. This is the kind of things that you can learn by reading the lecture notes and the bibliography. Just note that XML is very hierarchical. There are certain rules that must be followed so that you have a valid XML document. So this is not like HTML where you can open a tag and not close it. If you do something like that in XML, that's not a valid format. And that means that if you actually validate the XML document, the validation will say, this is not valid and it should not be used. Okay? And one of the things that you have to address in the first assignment is when you should use elements and when you should use attributes. And that's a question that many people sometimes have. Elements, as you know, are tags. Attributes are basically classifiers like the ID in this example. And if you look at this, it would be perfectly fine to have ID equals to on the CD tag, or have ID has the tag itself in the document. Okay? There isn't no clear rule on how to do this. Some rules of thumb is that, in general, if you look at an attribute is a single value, okay? And it's something that, in general, somehow identifies or classifies an element, okay? For instance, an ID, or imagine a color or a font in an HTML document. That's the kind of things that are attributes. They are classifying a certain tag. If you look at it, you can create things like lists using elements, but you cannot create lists using attributes, right? And in general, things like keys in a database, in many occasions are actually attributes, but that really changes from application to application. But at least you have these kind of rules of thumb. This is something also that you will have to decide upon when you do the first assignment, because you'll have to model some information using XML. Okay. Another important concept, namespaces. Imagine that you have two XML files which come from different domains. For instance, you can have a catalog of CDs and you can have a catalog of books. If you look at it, in many occasions, it actually happens that you are using the same tags. And somehow, if you have a large system and that system has to combine different XML documents, that's a problem. So in XML, one of the things that exists and it's used, it's something called namespaces. What you do with a namespace is basically to put a prefix. In this case, I call the prefix CD namespace, and that CD namespace is used to classify the tag. Okay? And in this way, if you use different namespaces for different tags, basically, when you are processing the XML in an application server or something like that, you can distinguish between tags that actually have the same name. One important thing, when you use a namespace, basically you have to pass a string that identifies the namespace. The string can be anything you want, but in general what people do is to put an HTTP address where the schema for the namespace that you are using and for the data that you are using is stored. This is not used to validate or to do anything like that, but it's a good practice. The primary key to identify a namespace is actually this tag, this string. Let me give you an example. Imagine that you have this document, this XML document, okay? If you have this XML document, this one. Imagine that you have this XML document. Very simple, it's a catalog with CDs, several artists. If I open this, for instance, in something as simple as a web browser, I get basically the file, okay? One of the things that you will learn, and you have lecture notes about that, and you will do on the first project, is that it's really easy to transform XML to something else. To different XML, to things like HTML, to PDFs, to whatever. And to do that, use something called XSLT, okay? XML Transformation Language. The way it works, it's very, very simple. Basically, if in your XML document you put a tag like this one, where you actually have a reference, and this reference actually identifies that you are using a transformation, what happens is that opening exactly the same file without doing anything basically transforms the file in something like this. Because you define a transformation file. And the browser is able to identify that you are doing transformations because you have that namespace and you have that particular string. Okay? So, how is the browser able to know this? Because when I wrote that document, catalog to XML, which I have put here, when I wrote the document, basically I said, I'm using this namespace which is stored here. And the browser looks at this string and it knows, oh, okay, I know what this means. This is a transformation and the namespace being used is basically the namespace corresponding to XML transformations. Okay? So it's a powerful technique to enable you to actually, on one hand, separate information in XML documents and do things like transforming documents and so on. Okay? Okay, some small relevant things. You can look this in detail later on, like things like white space is preserved, some names are reserved. These are little details that you'll have to address in your first project. Okay, this I'm not going to talk about today. Can I show you the first project now? Okay, let's look at the first project. Okay, so the first project, as I told you, is about XML and XML manipulation, okay? And the idea is that you gain familiarity and ease on how to actually use XML and process XML. How many of you have used regular expressions before? Okay, at the CMU size, everyone? Almost everyone. Okay, 3 maybe. Okay.
So four of 7.
Okay, excellent. So the people who haven't used it before, they will learn it. The ones who have used it will learn a little bit more about regular expressions because it's very, very used. And you will learn to use a technique called screen scraping. Screen scraping, what it means is that sometimes you have to integrate with systems that actually were not designed to be integrated. And when that happens, you can do it in different ways. One way, which is the most common, is go to the database and try to do something using the database, which is a pain and sometimes goes seriously wrong. And another approach that people use when they cannot go through the database is actually to manipulate the screen and try to gather data from the screen, directly from the application. This was really common in applications that used VT100 terminals and things like that, enterprise systems that were quite old, things that were running SAP and things like that. And it's very, very used. It's not pretty. Again, I'm not advocating that this course is pretty in terms of the technologies it uses, but it's something that people many times have to do. And in the case of this assignment, basically that's something that you will need to do. So you have the due date, you have the scheduled effort, you have a description of the final delivery, but the most important thing is actually the assignment itself. So in this assignment, what you will do is to go to a website called deepreview.com, which is one of the most well-known and regarded sites about cameras. They have a huge database about all the cameras that are available in the market. And basically what you are going to do is parse the information that is available on this website and generate an XML file containing the details about the cameras of a certain manufacturer. So the first application, you have an input string, which is a brand, for instance, Canon or Nikon or Pentax. And basically, you are going to go to this page. You are going to go to this page on the left-hand side. And basically, you are going to have to identify what cameras are, and you are going to have to visit the corresponding camera and gather this information. And you are going to have to model how you are going to represent this information. Let me give you an example. One of the things that is available is the resolutions that the camera has. And the camera can have several different resolutions. Imagine 4 different resolutions, 5 different resolutions in terms of size of pictures. How are you going to model this in terms of XML? Are you going to have a simple tag and comma-separated values inside that tag? Do you think that's a good idea? Sorry?
You can use IDs for that.
You can use IDs, you can...
Attributes, I mean.
Okay, but it's all inside a single tag?
No. For different resolution, different attribute.
Different tags. Okay. So in the past, I've seen people basically creating lists inside of a tag, which it's not very, very good design. Sometimes you will find out that some information is not available on the camera. So how are you going to represent missing information? No values. Okay? That's the kind of design decisions that we expect you to take and that you will have to justify later on. Okay? How you model information about XML, how you process information, and so on. So the output of the first application is basically an XML file which scheme you define, and that XML file has to contain at least that information. The way you do it, I don't want you to just use substrings and things like that. I want you to actually use regular expressions, which is a much more powerful way of doing it, and it's of widely use.
But why do you call it screen scraping?
Because you have a screen and you are taking information, pieces of information from that screen.
But you're reading it on HTML format.
Yeah. Okay. So can you press a button? So in the past, what happened was that it was not really an HTML page, but it was really a line terminal that was connected to a screen, a VT100 or something like that. So the name became screen scraping because it was a physical terminal. Nowadays, it's web pages and things like that, but the name remains. Okay? So this is the first application. Okay.
Just one question about the screen scraping. Can we use a script like a PHP script to parse the DOM and access the DOM instead of the page itself?
Okay, can you press the button? Okay, I'm not sure if you will be able to do that, because I'm not sure if the HTML that they have there is well-formed HTML, and if you try to put it in a well format and actually extract the documents, I'm not sure if it's going to be robust enough. I can tell you that sometimes it works if the site is more or less well-defined, sometimes it doesn't work. For instance, with the assignment of last year, it would not work. But I would prefer that you use regular expressions, okay? Okay. Another thing is that the way you generate the XML file, I don't want you to just to print screens or print lines in your code, okay? Some people actually generate XML by manually writing the XML, let's say. What I want you to do is to actually use a library to create the XML tree in memory and then basically output it directly, okay? And the library that you will be using, or that I recommend that you use, it's called JDOM, and it's really easy to use, and I provide an example at the end of the assignment. Okay. The second application is called Camera Summary XML, and what this does is basically gathering the files of several different brands and summarizing the information, okay? And the way the result is, again, an XML file, and what this will force you to do is to actually read the XML, create some structures in memory, summarize the information, which means visiting all nodes and so on, and basically dumping the information back to another file. Things that I want to see: the number of cameras present in the input files, the date of announcement of the most recent camera and corresponding model, date of announcement of the oldest camera and corresponding model, and so on. Again, the information should be correctly modeled, and you must if you don't know what's going to be the output of your program. Okay? So I want you to think, I don't want you just to write code, I want you to think about corner cases and actually how to model information. The third application is really very, very simple. It's called the Camera List Beautifier. And the idea is that you learn how to do XML transformation using that language that I told you. So in XML, because it's so structured, it's very easy to write a set of rules that says, for this XML document, I want it to be transformed in this way. It's a little bit like cascade styling sheets for HTML. But in this case, it's for XML. Okay? So the third application, what it does is to have an XML file, and by applying the transformations, you get an HTML file. Okay? Technology. You can do this in any language that you want. A lot of people use Java. I have many students also use Python, for instance, for doing this. Some people have used Ruby. Some people have used more strange things. I don't care, you can use the language that you want. I will be mainly focusing on how you model information and how you handle corner cases and so on. Okay? One important thing, you are going to use these applications again on the second project, third project, and fourth project. And the second project is going to be done in Java. okay? And actually the third one also, because you are going to use a certain application server and so on. What this means is that if you do it in Java, integration for the second project is going to be a little bit easier. If you don't use Java, what happens is that you have, for the second project, you will need to create a wrapper around the program that you have in the first assignment. That's perfectly okay, and that's something that happens many, many times when you are doing enterprise application integration. Why? Because you can have a certain system or a certain application written in a language, in a certain way, and basically it has to integrate with an application written on a different language. So a common technique is to wrap legacy code, and that's something that we'll talk about in the course also. So if you want to use Python, go ahead. I don't have a problem with that, but to know that you will need to wrap it later on. Okay, grading. The things that I'm concerned: quality of the data model and the scheme that you define, which means XML and the scheme data, the way the data is represented, the quality of the overall solution, of course, the quality of code, and how simple the system is, okay? Of course, you will need to defend the project, so the defense is also something important. So not only you need to be able to code well and implement good systems, you must be able to communicate what you do, and that's quite important. Okay, has support material. I've given you some examples about how to read and write XML using JDOM, so you can reuse the information and you can read the manual. I've given you some small examples about how to do XML transformations. These files are available in the support material. And I've also written a little bit of code on how to actually download a page from a web server. And you can reuse this kind of code if you need to. And that's the first project. Questions? You are too quiet.
Go ahead.
I have a question here.
Okay.
I saw that you asked us to write Ant scripts to run our Java code. I just saw that in the assignment, the PDF. So should we do only that, or is it okay if we can develop the project and submit that as a jar file or something which you can directly run?
Sorry, can you repeat that last part?
So the question was, do you have to provide the Ant script to build the project, or can you just provide a jar file that can run?
After completing the project, can I just provide the project to you?
No, you should provide a script or something that basically builds the project. Okay?
Okay.
And you need to provide the code, of course, of the solution. Okay. What else? Okay, so that's it for today. Thank you very much for coming, and see you next week. Go look at the syllabus and see the plan. There are some days with no classes, and there's a makeup class on one of the Wednesdays, so please add that to your schedule, okay? Okay, guys.
Thank you, Paulo.
See you.